Hello everyone, welcome to your third lab. In this lab we have a three-parter. The first one is about loops, which we've already done in your previous lab, so that should be fairly simple. In your second question you're going to make a function and call it. And then in the final question, you will be working with branches, which is also something you're familiar with, but we'll try to combine our knowledge and make something new. All right, so first off is the question about loops. So for this part, we've given you a assembly program called greatest.asm, and this is a partially completed program, and what it's supposed to do is it's supposed to find the greatest number in an array and then return its index. So our file is actually here. There's a high version, there's a low version, and here's the assembly. So inside the assembly, we just gave you the array, and you have to fill in here starting from address 0. But if we go ahead and look at the high version of the code, let's see what happens here. So in this code, we have the array, the size is defined, and we have a variable keeping the max and the max index. And what's happening here is a very simple while loop going through the array and comparing our max variable to each element of the array, and if they are greater, set the max to this, set the max index to this, and just continue looping over. If we look at the low version, it's pretty much the same. The only difference is, of course, how we do the while loop. So, sorry, this should be actually like this. Sorry. So here we have our while loop, and let me fix this part as well. And we're using the while template that we used in the previous labs, and we're using ifs to emulate our while. And inside the while is this part where we have our if, which is doing this. So let's go over this again. So I've defined my index, my maximum index, and then I'm doing the while. So this part is the conditional part of the while. And then I am comparing the current maximum value to my array element. And if my maximum is less than my array element, I am setting the new max and the new max index. And at the end, I'm incrementing my index and going back to the beginning of the while. So with that, you should be able to easily, I think, write the assembly version of this. So one important thing is we want you to find the greatest index and write it to 285. So we don't want you to find the maximum value. We want you to find the maximum index, meaning that if you look at our array here, let's see, what is our maximum value? 67, 79, 99. So in this case, my maximum value is 99, but my maximum index is going to be 22, right? Because the array starts at 100 and the 22nd element is 99, the greatest value. So the return value should be 22. All right, with that out of the way, let's continue. So yeah, with that, this lab is completed. I mean, not this lab, this part is completed. Let's go on to the second part. So in this second part, we'll see how to write functions in assembly. And in order to do this, we've actually given you two functions which you have to use. So in the given assembly file, we have two functions. One is an XOR operation, and the other operation is a function which counts the number of ones inside a number. And using these two, you're going to create a program that counts the number of different bits between two numbers. And the way we do this is, let me actually show you with an example. So let's have two numbers. Let's have A is equal to 7, and let's have B is equal to, let's see, let's say 9. And then we want to find the number of different bits that they have. So to show this, let's write these in binary form. So 0, 0, zeros, and at the end it is 1, 1, 1. And this is similarly starts with zeros, and then 1, 0, 0, 1. All right, something like this, right? Okay, so just by looking at it, we can actually pretty easily tell the number of different bits here, right? So all of these zeros are the same, but here these are different, and this is different. So the number of different bits in this case is going to be 3. But of course, we have to do this programmatically, so that is going to be a little bit different. So as we said, with this we have 3 different bits. But so how are we going to use the two functions that we gave you? So the two functions that we gave you are XOR and counting the number of ones. Now, before we can actually do something, let's remember how XOR works. So A XOR B. Let's see what this looks like. So let's do this for two 2-bit numbers. So A and B. And well, actually, no, let's do it for two 1-bit numbers. That should be enough. So 0, 0, 0, 1, 1, 0, 1, 1. And I'll start with this and a little bit. So XOR 0, 0 is going to be 0. XOR 0, 1 is 1. XOR 1, 0 is 1. XOR 1, 1 is 0. Okay, well, now let's take a closer look here. So 0, 0 is 0 and 1, 1 is 0. So these are the cases where A and B are the same, right? So if A and B are the same, I get a 0. If A and B are different, I get a 1. So this is actually very useful, right? Because this is exactly what we were looking for. We want to find the number of different bits. And if we use a XOR here, what we're going to get is this. So we're going to get zeros here. These are all the same. And then 0, 1 is 1. 1, 0 is 1. 1, 0 is 1. 1, 1 is 0. So these were the bits that were different, right? So now all we have to do is count these. And that is exactly what the other function does. So the other function is a function that counts the number of ones inside a number. So that is exactly what we're going to use. So our flow looks something like this. Let me rewrite these. A is equal to 7, B is equal to 9. And what we do is, let's say temp is equal to A XOR B. And then result will be equal to, let's say, number of ones in temp. So this is what we have to do. And these two are actually the functions that we gave you. So let's write it like this. XOR, let's actually write it like this. So function 1, this is XOR, and this is function 2, and this is number of ones. Now, doing it here like this is pretty simple, but the challenge is to do this in assembly. So the actual challenge is how to call these functions, because we've already given you the functions, so you only have to call these functions. And in order to understand that, let us see how we use functions. So let's write a simple assembly program here, starting from 0. And let's have a function defined in 100. Okay, so let's say this function takes an argument, adds 1 to it, and then returns it. So this is pretty simple function, but let's see how it'll work. So let's say add I, and I'll have my argument in 50, and I'll add 1 to it, and then I will return this and write it to actually let's actually first do this. So let's actually copy it first in order to, okay, never mind, this is fine. So we take this and let's write it to our return value, 51 to 50, and then let's jump back. So bzji, let's say 30, 0. Okay, so this is the basics of our function, and let me actually write down what I'm doing here. So what I'm doing here is, so let's call this function f1, where it takes a single argument and it returns another single argument. So it would be something like this, I guess. So here I'm just taking a is equal to a plus 1, and I'm copying this to our return value. Return is equal to a, and then go to return address. So few things that we have to discuss here. How did I get this a, and where am I writing this A, the return, and where am I going back to? So where is this return address? So let's talk about all of these. So when you're calling a function, there are a few things that you need to do. So the first thing is to take care of our arguments. So when I say arguments, I mean the values in here. So I need to copy the values that I want inside my arguments. So let's actually do that. So CPI, so my argument was in here, and let's copy a value into it. Let's say 60, right? No, well, let's say just 4 to keep it simple. So let me actually write the addresses down as well. So 50 is arg1. So well, let's just call it A. I just copied the value 4 inside my argument. Next up, we have the return value and return address. So return value is inside here. Return value. In this case, we just called it ret, so let me just call it ret. And we have the return address, and I put that in 30. So here, let's put a 0 in here as well. Return address. And then of course, one thing that we also need to note is where the actual function starts. So address 100, let's put that in 31. And let's call this function f1 start. So here I just said a is equal to 4. Next, let's set our return address. So 1 is CPI 30, and I'm going to put a value here. Let's leave it blank for now. Return address is equal to blank, because I don't exactly know which address I need to return to. So let's see that later. And so we've taken care of the A, the return address. So now we have to jump. BZJI, I need to jump to the start of F1. So 100 and 0. Go to F1. So once the very simple CPU does all of these, it's going to jump here and it's going to do this function. It's going to write it to 51 and then jump back to whatever's inside 30. So now we can actually fill in that blank that we left before. So we want the function to be executed and then turn back here. So in this case, let's put a 3 here. So the function is going, so the program flow is going to be 0, 1, 2, 100, 101, 102, and then back to address 3. So now the function has incremented my argument and written it to 51. So now I actually have my function, my return value, and I can use it however I want. Let's say you use this value and add it to some other value, for example. So that is basically it. So let me actually fill this one as well. This is just a random function. Temp is equal to temp plus return. And I wrote this part like this, but if I were to write it more like a high-level program, it would actually look something like this. So this part would be f1 and 4. So with this, I've called my function, and I'm actually doing this. So 51 is equal to f1 4. All right. Now that we know this, let's go back to our assignment and let's see what we can do. So again, we have two functions that we need to call, and in our explanation here, we saw how we need to call them. So first we need to do function 1, and then with the result of that, we need to do function 2. So the only different thing here is going to be the function 1 requires 2 arguments, so you need to copy both a and b into your arguments and then call the other function. And let's actually look at here. So this is the assembly that we have given you. I believe you're going to use 80 and 81. Let's see. Yes. So your A and B is 80 and 81. And you're going to write your result in 110. So let's look back. These are our values. This is my function 1. This is my function 2. And here we've also given you the return address. And let's see, anything else. So this is your result. And that's it. And let's actually look at where our arguments are as well. XOR entry point get argument 1 to 100. So your arguments should be in 300 and 301 for this. And for the second function, your argument should be in 450. And I actually think we have this, yes. So the function starts at 250 and your arguments are 300 and 301. For function 2, it starts at 400 and it takes the argument from 450. And the result is in 451 for this one, 302 for this one. So with that said, that is the second part. So let's go on to your final assignment here. So in this assignment, you are going to generate a new function. And this function is going to be similar to the instruction BZJ, but it's going to be slightly different. So in BZJ, what we do is we check if a value is equal to 0 and then jump. But in this case, we are going to compare two values, and if those values are equal, we are going to jump. So let's actually write this down. So BZJ, A and B was, PC is equal to the value, sorry, first let's write the thing, B is equal to 0. In this case, it's going to be A or PC plus 1. So stars, let's not forget our stars. There we go. So when using BZJ, if the value of B is equal to 0, we jump to the value of A. If not, we increment the PC by 1. But in this case, we have a function, B and J. And again, we have two values. Sorry, we don't have two values. Let's see. This function will take the address we need to jump to and the two values to compare. Let's call these X and Y. And what this does is PC is equal to if the value of x is equal to the value of y, your PC will equal to a. If not, increment by 1. And that's it. So for this function, it's going to be similar to the ones that we've done before. So you're going to have your arguments, which are actually these. You're going to have your return value, and you're going to have your return address. Well, in this case, you don't actually have a return value, right? Because if you were to write this in terms of C, this would be a void function. You don't actually have to return anything. You just have to change where you jump to. And where you need to jump to is either A, or it is going to be your return address. So if this is satisfied, this condition is satisfied, instead of going back to your return address, you will go to the address in A. And that's it. So with that, I think the lab is pretty much complete. And here you're actually given the numbers. So we didn't give you a file, but as you can see, your arguments will be 120 and 121 for x and y. So let's actually write those down. So x is in 120. Let's show it like this. Y is 121, and then the jumping address is 122. So the A in this case is 122. And then your return address, the one that you jump to if this condition is not satisfied, is in 110. So return address is equal to 110. So I guess one final remark that I can give you is, well, what to expect from this assignment. So the challenge for this assignment is going to be x is equal to y, because we do not actually have a equals operator, an equals instruction. So you're going to have to come up with a way to compare x to y. So that is the actual challenge of this assignment. Other than that, it is a simple jump operation. You either jump to A or you jump to PC plus 1. Well, in this case, it's not going to be PC plus 1. It's going to be return address, basically. Okay, so with that, I think the lab is complete. So we've given you the files that you need to send, and we didn't actually add it here, but you will also send the bnj.asm. Alright, so thank you for listening. This was your third lab, and see you in the actual lab lecture.